try to get started. Okay, so we're going to start the second section. Okay, we have to start the second section of chapter 5. So in the first section, we graph one line, we graph a second line, and we would see where they would cross. And their crossing point was the solution to both equations at the same time. Okay, we are going to do, we're going to find that crossing point, but we're just not going to graph. Okay, and so actually this version I tend to like a whole lot more because you don't need to graph. And what if they cross at not a nice neat spot? And that is what we're going to learn today. Okay, we're going to learn to solve systems of equation by the substitution method. What we did in 5.1 was the graphing method. Okay, and then we're going to use those to solve real life problems. That'll just be kind of our word problem learning target, which will kind of progress through the entire chapter. Okay. In general, using the substitution method, you want to solve one of the equations for one of the variables, meaning it's in the form x equals something or y equals something. You want the x or the y all by itself. Because once you know what x is equal to, or you know what y is equal to, you can replace that in the other equation to actually solve for their literal values. Okay. I'm probably going to do all three of these problems on this front page here together. Okay. So just save yourself a little bit of space to actually be able to write down 4 total problems. Okay. You need to be able to get in the habit or a routine of understanding that when it says y equals negative 2x minus 9, and I ask, what does y equal? It equals negative 2x minus 9. That's all the information that we have. It's really natural for us to want to say, hey, it's just equal to 4. It's just equal to 5 or whatever. Well, here it's equal to an entire expression. Okay, so it's equal to negative 2x minus 9. Okay. And what variable is equal to that, though? What does it say? What does it say? It says y equals that. So in the other equation, what variable is going to get replaced if it says y equals x? So I'm going to replace all x variables with what y is equal to? Not quite the case. What are you going to do? You're going to take what y is equal to and replace y with what it's equal to. Okay. You have yet to have a problem where it says x equals 4 and you replace all the y's with 4. If x equals 4, you replace all the x's with 4. Here we know what y is equal to, so I'm going to replace that. Notice that I'm not replacing the 5. I'm replacing only the y, and I'm going to wrap it in parentheses because I need to multiply 5 times y, and additionally, it serves as a little placeholder of where y was at previously. All right. This is quite the crucial step. Do I have any questions about that? Okay. So I have a number next to a set of parentheses. What do? Multiply, which is the distributive property. Negative 5 times negative 2x. Negative times a negative is a 5 times 2 is 10. So this is 10x. Now I have to do the same thing here. Negative 5 times negative 9. Negative times negative is a positive. 5 times 9 is 45. Okay, what can I do at this point here? Combine like terms. I have a 6x and a 10x. What do 6x and 10x combine to?
16x.
How do I solve for x here? Minus 45. You can get a calculator out. You can just go negative 19 minus 45 in your calculator. It would tell you it's negative 64. And what's the last thing I need to do here? Good. Questions about that? Okay, my guess is most people's intuition is that we're done with this problem, but we're not. Because remember, when I'm trying to find where they cross, I need an x value and a y value. So knowing I know that x is equal to negative 4, how can I find the y value? As I can replace all x's with negative 4. Does it matter which equation I use? It does not. My suggestion is whatever you boxed in will tend to be the easiest. So I'm taking that top equation. I know x is negative 4, so I'm replacing x with negative 4. And now I just have to actually solve for y. So I'm going to go negative 2 times negative 4. Negative times a negative is a. And then 8 minus 9 is negative 1. So if I were to graph these, I would find that they cross at the ordered pair negative 4, comma, negative 1. And that would be my answer. Okay, so you should find an x and a y when you're doing these. Okay. Each of those monitoring progress problems have their own kind of unique thing to them. So I'm going to go through all three of those with you together. Okay. All right. Let's do number 1, monitoring progress number 1. What's unique about this one, do we think?
Y equals 4, negative 4x.
Okay, yep. They're both actually y equals, right?
Yeah, but 4x doesn't have anything after it.
Doesn't have anything after it. It actually kind of makes the problem easier. Okay, I can still take what y is equal to, and I can still replace the y. The other thing that makes this problem unique is my variables are now split by an equal sign. Okay. So I need to get all my variables on one side. In this situation, I'm going to want them on the left side because there's no addition or subtraction with this x term. So I want to look at the other side and say, how do I get rid of 3x? That's a positive 3x. How do I cancel that out? Minus them. Now, how do I solve for x? Divide by negative 7. Okay, and again, if you didn't know those facts, like you didn't know 14 divided by negative 7, you could just use a calculator. That's nothing wrong with that. In fact, I would encourage it. Okay, am I done? Because gotta find the y value. My suggestion again is whatever you boxed in will tend to be easiest, not always. Negative 4 times negative 2. Negative times negative is positive. 4 times 2 is 8. So this crosses at the ordered pair negative 2, comma 8. Questions about monitoring progress 1? Okay, let's do 2. really the only thing unique about 2, and if you need scratch paper, you're running out of space, there's some in the back, or I can get you a little bit of space. The only thing that's unique about 2, in my opinion, is that it has a fraction in it. Now, granted, it's a pretty easy fraction to deal with, but I understand that you all hate fractions with a fiery passion. Okay. First off, is this problem say x equals or y equals? Do I have an x equals equation or a y equals equation? Y equals, so what variable is going to get replaced? Y. So I'm going to take this, what y is equal to, and I replace the y in the other equation. I have a number next to parentheses. So what does that indicate for me? Distributing, which is multiplication. Okay, I'm not going to distribute this 3x, so I'm just going to bring it down. And now let's talk about how, when you multiply a whole number by a fraction, for the most part, you should be able to do a good amount of them in your head. That being said, if you don't know, just use a calculator. All right, remember 2 and what with the top number? What do I do to the top number in 2? Multiply. So I'm going to go 2 times 1. What's 2 times 1? Divided by 2. Whoa. Okay, 2 times 1 is 2. 2 divided by 2 is 1. So it's a 1x. 1 divided by, yes, you could do that. Okay, and then 2 times -1 is -2. All right. Do I have like terms?
Yes.
What are my like terms?
3x and 1x.
3x and 1x. What do 3x and 1x combine to?
4x.
What do I do to solve at this point here? I could divide everything here by 2, but I'm going to add 2. Okay. And then divide by 4 to find out that x is equal to 0.5. Okay, I'm going to take this 0.5. I'm going to replace this x right here with 0.5. Then -1. All right, multiplying a number times a, I don't think we've ever done a decimal times a fraction, but you can do the same rules. 0.5 times the top number, so 0.5 times 1, 0.5, 0.5 divided by 2. So 50 cents divided in 2. 0.25. And then 0.25 minus 1. Be negative 0.75. So my answer to monitoring progress, 0.5 comma negative 0.75. And again, this part was the original problem. So it takes a good amount, not like a ton of work, but it takes a healthy amount. So again, you need some scratch paper. I just write small, so because you'll probably lose the scratch paper. All right. So monitoring progress 1 was weird because you set them equal to each other. Monitoring progress 2 just had a fraction in it. There's really nothing else there. Monitoring progress 3. What's unique about monitoring progress
Or
through?
X equals.
It says X equals. Okay. So since it says X equals, what do? You replace the X. Okay, so the only difference in this 3 problem compared to the other ones is you're replacing X instead of replacing Y. But the thing that's nice is nothing changes. I'm going to zoom through this a little bit quicker. Then I replace that one with Y. So here, I distribute 6 times 4, 4 times 6Y is 24Y, 4 times -7, -28, 24Y and 1Y combined to 25Y. Add 28 from both sides to get 25, divide by 25 to get 1. And then there is my final answer. All right. Again, I went through that one a little quicker, so I'll give you a second to write, but. Is there something I can clarify? Okay, because I'm going to add one little extra wrinkle to it, but then besides that, everything's the exact same. Like the more difficult problems are just like one little extra stuff. All right. What do you do if it's not just X equals or just Y equals? Well, what you can do is you can find a positive 1X or a positive 1Y. And it doesn't matter which, and it doesn't matter what equation. You just want to try to find one of those. Anybody see a positive 1X or a positive 1Y? Where? Y in the top equation. Okay. So I'm going to take that top equation. Because if I just have Y, that's 1Y. And I am going to get this thing all by itself. How do I get that Y by itself? Plus X on both sides. I wasn't sure if that was X with a little accent, but. And then here I could write 3 plus X or X plus 3. I'm going to write X plus 3. Is my Y by itself now? Yeah, sure is. So now I can take what Y is equal to, and I can replace the Y right here. Since there's no number multiplied by the Y in this problem, I do not have to put parentheses around this. If I had 2Y, then I would go 2 parentheses this. Since it's just Y, no parentheses needed, and it would look like this. 3X plus Y, the Y is X plus 3. All right, what can I do from this point? Combine the x's into 4x's. And then minus the 3, yeah. Best place to me to replace your x back in or your y back in is whatever's in your box. So these two things intersect at -1, 2. And if you remember last time when I showed you how to check if something is indeed a solution or not, you can do the same thing on these problems. It's just most students I know don't do that. And I don't even do that myself, honestly. So, okay. Do I have any questions specifically on the little extra bit I added? Like right here. Added to it. Okay, I just want to look at the monitoring progress ones, and we're going to talk about what variables you could get by itself. Okay, we're not going to actually solve them through. Okay, if as I look at 4, could I get this x by itself fairly easily? Yes, all I would have to do is minus y. Could I get this y by itself? Yes, all I'd have to do is minus x. Could I get this y by itself? How would I get this y by itself? Add 3x. Okay. What about a number 5? I'm going to zoom in a little bit. What about number 5? Could I get this x by itself? Yeah. I could. It would require more than one step, though. I would have to minus y, then divide by -1. So I would suggest not getting this x by itself. But could I get this y by itself? Yeah. And how would I do that? Adding x. Okay, same kind of thing. I could get this y by itself, but I would have to do more than one step. So to me, if I was doing this problem, I 100% would be getting that y by itself. Okay, look at number 7. What variable in what equation would be just the best one to get by itself? X in what equation? X in the top by a lot. It's one step, add 2y. Okay. Now, as you look at 6, though, you don't really have a choice. You're going to have to do some extra work at some point. To me, I would try to get one of the y's by itself. Okay, I'm going to show you how I would get this y by itself. If I wanted to get that y by itself, I'd have to get rid of this 3x. Is that a positive or negative 3x? Positive, so I would minus it. Okay. If I have minus y, that's minus 1y, and I would divide everything by -1. Negative divided by negative is positive. 3 divided by 1 is 3. Positive divided by negative is negative. 1 divided by 1 is 1. So that's how you could do. If you have to do 2 steps, you have to do 2 steps. Okay. But at all costs, if I'm you, I'm trying to do the least amount of steps as humanly possible. Okay. We're going to move on to word problem. You're going to have to get used to them. And I do feel confident in everybody's ability to figure these out. Now, here's one thing that you all should do is start a drama club, because let me tell you, this has been a very drama-filled year so far. So I feel like if anybody wanted to do one and do it right, we're looking at the group right now. Okay. So a drama club earned, that was me taking a shot at all of you. Okay. Okay. So a drama club earns $1,040 from a production, An adult ticket costs twice as much as a student ticket. Okay, write a system of linear equations that represents this situation. And then what is the price of each ticket? Okay, let's first talk about this statement. That second sentence. An adult ticket costs twice as much as a student ticket. Okay, I don't know what the price of an adult or a student ticket is. I do know how many are sold. So those are going to be my variables. That second sentence is very, very important. It's going to allow us to write an equation, but my guess is it's also going to throw some of you off a little bit in terms of writing the equation. I think the concept is fairly easy. It's just like writing the equation. I think you guys are prone to screwing that up. All right. Let's pretend that my adult ticket is $10. Just I'm making it up. I just want you to understand the relationship. Let's pretend my adult ticket is $10. What's my student ticket? $5. Let's pretend my student ticket is $15. What's my price? $30. Let's do one more. Let's pretend a student ticket is $40. What's my adult? Okay. I feel confident we understand the relationship. Now let's write the equation. You have to, and there's two different ways that you could do this, okay? You can say, how do I say my adult ticket price compared to a student or my student compared to adult? It doesn't matter. I'm going to say adult compared to student. I know that an adult ticket is equal to, what do I have to do to the student ticket number to get my adult ticket number? Times it by 2. So my adult ticket is equal to 2 times S. And I think a lot of people would put the 2 with the A because they say the adult ticket's twice as much, but actually in the equation, you have to multiply the S in this situation by 2. Okay, do I have any questions about that? If you struggle to write that equation right away, just create yourself a little table. Okay, let's do the other one. Okay, the other one is going to represent the money, the total money. Okay, how much total money is being earned here? $1,040. Okay. And they what? They earn 520. How do you know? But that's assuming that the same number of students and adults went to the thing. Okay, which is possible. I'm not saying, I don't even know what the answer is here, but that is definitely possible. Okay, how many adults went to the show? So whatever the price is, I have to take 64 and I have to multiply it by the price of an adult. So 64 people times the price. How would I represent the second part for students? 132S, okay? This is a test question. You're currently at 3 out of 4 points. Writing it's the most difficult part. Okay, how can I solve this? This is a great problem for substitution because my A variable is all by itself. So I can take what A is equal to and I can replace it in the other equation. I forgot to mention this earlier. After you do this little substitution, if you have more than one variable, let's say you have A's and S's or X's and Y's, you substituted it wrong. You should notice how I have only S's. That's kind of the way it should be. Okay, so here I have to go 64 times 2S. (64 times 2 is 128. (128) 132 is 260. And then how do I solve here? Divide. So S equals 4 rep means what thing? What does S equal 4 mean? Yep, a ticket for a student is equal to $4. Okay, I can take this $4 and I can plug it back in. 2 times 4. Two times 4 is 8. So an adult ticket costs $8. Okay. All right. I'm going to write down what the practice problems are, but then what I want to do is I want to do number 27 from 5.1 for you all, because I just know the word problems are tougher. So I want to give you a little bit more information on how to do those. Okay. Okay. So practice problems look like it's 3 through 16. So the 5.2 practice. That was short. I like that. This will give you plenty of work time. But remember, I'm going to do one more problem after this. Number 3 through 16, 19, 20, 25, and 26. Okay, it looks like I underlined 25. So my guess is that's a word problem, and that is most similar to your learning target / test. Okay, so when you're doing this, minimum practice is one word problem, one like regular other problem. Okay. Okay. Otherwise, let's backtrack a little bit. Let's go to the 5.1 practice problems, and I'm going to do number 27. Okay, if I can get this to focus. Last class was having a heck of a time. It would not focus for me at all. Okay, number 27 from 5.1. This is page 224. You have 40 minutes to exercise at the gym and you want to burn 300 calories using both machines. How much time should you spend on each machine? So that question being asked kind of tells you what the variables are. Okay. For me, E is going to represent time on elliptical, if I know how to spell that. I can't spell. And S is going to be time on stationary. Okay, let's focus in, please. All right, so there's two things happening. The first is that I'm spending 40 total minutes. The second is I'm burning 300 total calories. First off, I think if you gave me 40 total minutes in my entire life on either of those, I can't guarantee I've hit that mark yet. One day I'll hit 40 total minutes at the gym, but yeah, one day. Okay. Anyway, so the first equation is going to be representing just time. If the first equation is just representing time, what's the second equation representing? It's the other thing. Calories. Okay, let's do calories first because I think that will be the easiest one. How many total calories were burned? 300. Okay, so you can spend 40 minutes at the gym and burn off like one Mountain Dew. Maybe, if you're lucky. All right. Here's the thing. You need to understand that this is 8 calories per minute, right? Minute on the elliptical. Well, what represents minutes on the elliptical? E. Okay, so how do I represent burning 8 calories per minute on the elliptical? 8E. Plus 6 calories per minute on the stationary. 6 calories per minute on the stationary. How do I write that? 6S. Okay, do I have any question? Most of you are actually, I would say, fairly good at getting this part. Okay, it's the other one that I think throws a lot of people off. Okay, time. What's the total time? Okay, ready? Okay, I want to try to clarify this for everybody. So I'm asking you to be quiet in the nicest possible way I know how. So I got more not nice ways than nice ways, but I'm trying to keep it cool. All right, here's the thing. Everybody wants to throw this 8 in the S or the 8 and the 6 into the minute one. That doesn't make a whole lot of sense. Mr. Bully, how much time did you spend on the elliptical this morning? 8 calories. What would you were expecting? You were expecting time on an elliptical. What represents time on my elliptical? E. Am I going to have the 8 there? No, because this top equation has nothing to do with calories. Okay? But it's not just the time on the elliptical, it's also the time on the stationary. Okay? So it's just E plus S. So on the candle problem that a lot of people were working on last class, you were trying to put the money with the candle. So when there's only 24 candles, it's just large candles plus small candles. That's what a lot of people were missing this equation. All right. Again, if this is a word problem on a test, you'd be at 3 out of 4 points. Do I have any questions? Okay, let's actually solve this. Okay. Okay, if I want to graph this, okay, if I want to graph this, I need to find the E-intercept and S-intercept. What's an important fact we should know about the E-intercept? 8 calories per minute, not wrong. S equals 0. It's a little bit more tricky when I have like 2 not X and Y. But if you have an intercept, that means the other variables are 0 automatically. Okay, so for the top one, S equals 0, so S goes away. So that means just E is equal to 40. So my E-intercept is 40. Okay, let's do my S-intercept. That means E would equal 0. That means E would go away. So that means S is equal to 40. And what does this mean? This means if you spend 0 minutes on the stationary, you spent 40 minutes on the elliptical. If you spent 0 minutes on the elliptical, you spent 40 minutes on the stationary. Okay, let's do the bottom one. Bottom one's a little bit more difficult. Okay, we're going to do the same thing. We're going to find the E-intercept. E-intercept means S is equal to 0. If S is 0, the S term goes away. So this is now done disappeared. And now we're left with 300 equals 8E. Okay, and then I would divide by 8. Say that the E-intercept is 37.5 for the bottom equation, for the calorie equation. Okay, then I'm going to do the S-intercept, which means E would equal 0, which means the E would go away. Yep. I could probably show you a handful that are probably double or triple up that you will be doing one day. You just haven't had the privilege to do yet.
Yeah.
All right. Okay. So I found the E and S intercept from all of these because that's going to help me determine what to go by on my axes. Okay. I have all four, I have 50, 40, 40, and then this weird 37.5. This tells me I can probably go by fives. If everything was multiples of 4, you could go by 4s. Everything was a multiple of 3, you can go by 3s. Okay. I'm going to call this E and this S, I suppose. Okay, I'm going to go by 5s. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Same thing the other way. Okay, we're nearly done. I think all the hard stuff is done right now. Okay, I'm going to graph each of these. E intercept at 37.5. Here's 30. Here's 35. Here's 40. 37.5 would be exactly in the middle, right here. Okay, and then I also need an S intercept of 50. That's way up here. Okay, now I need an E and S intercept of 40 for the red equation. That'll be here and here. Well, I must not have drawn my line very well because okay. All right. Okay, so where did they cross is my answer. So that's right here. 30-10. So that would be 30 minutes on the elliptical and 10 minutes on the stationary. Okay. All right. So what I'm going to allow now is about